Hello, everyone, and a very warm welcome to the session today. My name is Govind. I represent GlobalSign, and I'm part of the sales engineering team for the EMEA region. The topic for today's discussion is identity for everything, securing and automating high volume deployments. Just to quickly introduce GlobalSign to those who don't know it already, GlobalSign is one of the oldest publicly trusted certifying authorities, which means we are in the business of issuing online trusted identities to anyone and everyone. It could be an end user like you and me. It could be a device like a laptop or a server. It could be the IoT, the Internet of Things, the Internet of Everything, the things. We can issue identities to pretty much anyone. And that is our punchline as well, which says identity for everything. We are very well positioned to to cater to the massively growing business of IoT security. And one more very unique and important point is that we are the only public CA who has a full-blown IAM arm, which makes us quite unique that we do PKI and we do identity and access management combined, and we have complete portfolio of solutions to cater pretty much any requirement in any of these two spaces. So the agenda for today's discussion is going to we'll first discuss the challenges associated with managing large volumes of identities. We will then talk about how do we overcome these challenges with the unique set of solutions and services that we offer from our PKI and our IAM division. And lastly, for the first time, we will be talking about some of our third-party integrations and some of the interesting use cases, which basically highlights the kind of integrations that GlobalSign has to effectively help our customers and our partners fulfill the requirements and the gaps and the pain points that they have in their day-to-day lives. So, to talk further about what GlobalSign does, I wanted to talk about the problems we solve. On the right-hand side, you can see there are a set of services which could be either on-prem, and most of the services that we are offering are our cloud-based offerings. You can, in the middle of the diagram, you can see there are a lot of different types of services, different types of security features that we provide. It could be single sign-on, identity federation, it could be PKI-based digital signatures, e-services, and then of course which provides you authentication, access control, authorization, and encryption. And there are a few more to talk about. On the very bottom, you would see the different entities which consume these identities. It could be the things, as I mentioned. It could be a mobile device, it could be a machine, it could be a server, users, applications, documents, transactions, and so on and so forth. So the very first problem that we solve is to reduce the time and the cost to deploy enterprise PKI. Enterprise PKI deployments can be big, they can be medium, they can be small. One very interesting point to keep in mind is that when we talk about PKI, the initial effort and the setup is not dependent upon the number of certificates that would come out of that PKI infrastructure. There is there's a minimum effort cost that goes in order to be able to have a production grade PKI setup up and running, and we help reduce the time and the cost in doing that. We help manage very high volumes of identities for IoT and IoE, which again is becoming very important with the growing business, the growing need and demand for these kind of IoT and connected devices, and the security about these IoT devices. Very recently, as recent as just a couple of weeks ago, there was a massive internet breach where the DNS servers were targeted with DDoS attack, and it resulted in 80 major global websites rendered non-functional for many, many hours. Very quickly, it was identified that the massive attack originated from IoT devices. The bad guys took over large number of IoT devices, including CCTV cameras, and they utilized the live video feeds to target the DNS servers, which effectively resulted in a lot of websites going down, which basically highlights the importance of IoT security. To have connected devices is not just enough, we need to secure access to those connected devices. That's equally important, very important. We help to manage the certificate related risks, for example, compliance. It could be a certificate which could expire, and accidentally the administrators may not renew the certificate, and then there are many other risks associated. Risks could be associated in terms of protecting the root keys. A lot of customers I talk and meet usually don't use hardware security modules or HSMs to protect their roots. That's again a problem. A lot of customers don't have certificate policies or certificate practice statement around their PKI infrastructure. Again, uh, those are the areas, compliance areas, where we help reduce the risk. Lastly, we reduce the time to deploy identity and access management solutions from months to weeks. IAM solutions are very important when it comes to identities. The PKI side of the business basically helps us issue an identity, and then we can easily manage the life cycle of the certificate from within the CA software. However, when we want to use that identity on different platforms, different applications, then we need IAM type of solutions. So before we talk about the solutions, I wanted to spend a couple of quick minutes to understand the challenges of using an on-prem CA. Now, we have some assumptions here. We are assuming that this is a two-tier PKI. There could be more tiers. It could be three-tier and more complex. We are assuming that we are assuming that we have an HSM, at least one HSM to protect the roots. And the third assumption is that the customer would have some sort of compliance around their PKI infrastructure, which means at least they would have a certificate policy and a practice statement around their PKI. If a customer does not have any of these assumptions, obviously the effort and the cost that we will talk about would be less, but this is the basic assumption. The very first point to keep in mind is that the implementation time frame typically would be 3 to 4 months. Uh, this is a very aggressive time frame. The usual, the what we see normally on the ground, the implementation time frames are much higher than 3 to 4 months. This is a very aggressive time frame that I've taken. There's a lot of documentation which a customer needs to write those documents to get them approved and maintain that documentation over the life cycle of the PKI project. There are a lot of software costs associated. Customers, particularly in case of Microsoft PKI, feel that the uh, PKI is free. The certificates are free. They come from Microsoft operating system. So why bother? Why even evaluate anything else? Which is true that those certificates are free, but then there are a lot of associated costs. There are a lot of accessories that go in with the Microsoft CA, and one of them is the software cost, which is the base operating systems. They're not free. If you're running in any form of virtualization environment, those virtualization licenses are not free. And then even a massive cost goes in hardware. You need servers to deploy root CAs, issuing CAs, CRLs, OCSP, storage, HSMs, load balancers, so on and so forth. Compliance cost. Writing and upgrading the certificate policy and the practice statement itself is a hectic task because it's a living document. It basically keeps on getting updated every few months. And then if you have any industry vertical regulation, for example, FIPS compliance, then you need to be sure that you are running on HSMs and any other components needs to be FIPS compliant. You need to have multiple teams, resources who are involved for implementation, infrastructure, cybersecurity. Depending upon the kind of SLAs you have, you need a support team. And then the salaries for all of these teams. As most of you would be aware, salaries are the single biggest uh, expenditure that a company has to incur. and that's why it is very important to keep in mind that what kind of and how many resources you would have to employ and manage just to run your PKI infrastructure. Replicate all of these at the disaster recovery, and the cost goes further up depending upon whether you have 50% or 100% capacity. Your costs and your efforts will be accordingly. All of these put together on a 5-year tenure, and our estimates tells us that this cost will be between 800K and 1 million USD. As I said, this is based on some assumptions. If there are customers who are not running uh, the PKI with any of these assumptions, the costs can be lower. There are customers, by the way, who have costs much higher than the estimates that we have. So, talking about the solution to the challenges I just spoke about is to automate as much as implementation and even the management part of it, and then obviously go in cloud so that whatever you're doing, you don't have to do it on prem. It can be simply be running in the cloud. And one of the solutions that we have today to talk about is for internal users. And the offering we have is called Auto-Enrollment Gateway. So AEG is a cloud equivalent to an on-prem CA. So what we say is that whatever you do with your on-prem CA, we can do all of that in cloud. So AEG is a connector between Windows environment. And the diagram you can see you have Windows Active Directory on the left hand side, and you have a GlobalSign SaaS CA on the right hand side. And in between, you have AEG, which basically connects your AD environment with GlobalSign SaaS CA. And the solution is custom designed to understand AD policies, AD repositories, and whatever you need to do, AEG is able to understand those policies, get those certificates generated, push them to the endpoints, and job done. This allows the organizations to automatically enroll, provision, and manage the certificates to all Windows connected devices. It could be servers, it could be laptops, so long as they're Windows domain joined, it can provision certificates. So this is just another overview, another diagram to highlight what AEG can do. And on the left side, you can see your Active Directory. In the middle, there's a tiny connector that is AEG, which gets deployed in your environment. And then on the right hand side, you have the GlobalSign SaaS CA. I have a quick demo to capture what I just spoke about, and I would like to play that now.
The Auto-Enrollment Gateway is a crucial piece to the enterprise certificate management puzzle. Instead of running an internal CA, a process that requires advanced knowledge of complex PKI environments, significant time, and human resources, enterprises can outsource certificate services to GlobalSign's highly available world-class CA infrastructure. Serving as a proxy between an organization's Windows environment and GlobalSign's SaaS CA, the gateway leverages Windows Server and Active Directory capabilities, allowing for a transparent certificate management experience, including auto-enrollment and silent installation of certificates. The Auto-Enrollment Gateway makes it easy to issue and manage certificates across your entire organization for a variety of use cases, including authenticating users to private networks or other corporate resources, server-to-server communication, machine and device authentication, secure email and document signing, and smart card and USB token-based authentication for privileged users requiring two-factor authentication, all without the burden and risk of running an in-house CA, leaving you free to focus on, well, anything besides PKI. Stay secure and do more with less IT investment with the Auto-Enrollment Gateway from GlobalSign.
So I hope this was a good video to cover and summarize what the solution is. Moving forward, talking about general use cases, I would quickly scan through this slide, and it talks about pretty much all the use cases that you can think of. SSL, SBIME, smart card authentication, machine authentication, domain controller, PDF signing, and all of that you can think of are the use cases which AG can help you issue those kind of certificates. One thing to keep in mind is that it can support all the default certificate templates that are available with AD. The solution can support all of them. Solution benefits. The most important benefit is that this is a zero client footprint solution. You don't have to deploy any software on the Windows joined, domain joined endpoints. And in a pure clientless environment, we can push certificates to the endpoint. It supports a variety of use cases, which we just discussed in the previous slide. Supports both private and public certificate types. Just because GlobalSign is a public CA does not mean we can only issue public trust certificates. We can help you with the with private trust certificates as well as public trust certificates. There are a lot of use cases. We discussed a few of them in the last slide. For example, machine auth, client auth, any form of two-factor authentication where the users do not go outside the organization. You basically need a private trust, and that's what we can help you achieve as well. It reduces the risks associated with in-house PKI operations. As I mentioned, there are a lot of times situations where customers do not have the best practices deployed. For example, lack of HSMs, lack of the knowledge how to manage those HSMs, uh, not having certificate policy or any sort of compliance. These are all risks that usually we see. The moment you go on SaaS, the moment you go into our cloud environment, we basically guarantee a basic bare minimum security level, which comes from our WebTrust compliances, our CAP forum compliances, whereby we first publish our certificate policies and practice statement, what and exactly how we are going to do that, and then we strictly abide by that because we have an ongoing web trust audits. So which basically means you can be rest assured that your routes, our routes, and if we have to host your routes for whatever reasons, will be secured in a specific way, in a specific fashion. What are the access control capabilities we have built around that? What kind of infrastructure we have? All those things are very well documented and they're audited. So that is why we say the security basically goes up as against a normal convention, that security goes down when we go on cloud. Enterprises retain the control of users and policies. Very straightforward. It means that we do not have any access or write access to the AD. We only have a read access to the Active Directory, which means we cannot write anything on your Active Directory. We can just read from the AD, which means we are non-intrusive in nature. Minimizes the total cost of PKI deployments, which we discussed. There is a massive cost associated, and with a solution like AEG, the costs can go down up to 50 or up to 70%, depending upon the use cases and the types of certificates you want to you require. One of the most important points is that this solution was developed by ex-Microsoft crypto team. This was the same team who actually wrote the source code for ADCS, Active Directory Certificate Services. It's the exact same team who worked for us as contractors and who have developed the solution. That's the reason why we have so tight integration with Active Directory without having a need of in-client software. For external users, where the users are not part of the domain or not part of the organization, and these external users could be citizens, let's say, or could be end users of our customers who are not in our domain, basically. To describe that, we have taken the typical example of an IoT space. You can see there are a lot of different services, web portals, which are available over here, and we see how different entities connect to these services. So we have the things that connect to the web services. We can have a user or consumer connecting to these things and then connecting to a web portal. We could have administrators connecting to admin portals. We could have our suppliers, partners, and vendors connect to our web services, which could be internet facing. And then we have these third-party applications which connect to different web services and the users. It's a complex mesh. And then comes the identity service providers like GlobalSign, who can help customers with authentication, authorization, identity relationships, and so on and so forth. Now we talk about trust. Now, depending upon the kind of connectivity you have or you want to establish, you would need to have the corresponding type of trust for that particular use case or for that particular scenario. So if you have the things connected to web services, you only require private trust. If you have end users connected to these things or to web portal, you need public trust, or the trust could be scenario dependent. A thumb of rule is that if you are connecting or if you want to connect to an internet facing service, you typically require public trust on the server or on the website. So that is why we see that a public trust is required when you connect to a web portal. When the administrators or business users connect, which means your internal portals like VPN, Exchange, your Salesforce, they need private trust. Vendors connecting to your internet facing websites and web portals obviously need public trust. And you also need public trust when you have application to application communication. Now, these red arrows over here basically show that what a identity provider like GlobalSign can help you with. We can help issue these identities in form of a digital certificate through APIs or through different delivery channels. Uh, those channels and solutions will differ depending upon the use case you have. But in short, it means that we are in a position to help you identify your needs and then issue those certificates to those endpoints. As I said earlier, IAM is a very important part, very integral part of the identity services. After the certificate is issued, and if you need to manage that particular certificate on different applications, you need something called the IAM services. Now, there can be different components. You could need a certificate management on different applications. You may require something like a self-service portal where users can reset the password. You probably might require a role-based access. So once an identity is issued, and then after that, you need to decide what a user can do with this identity on different applications. So the best analogy I can draw here is a passport and a visa. A passport is your identity. It tells the authorities who you are, and that's what a digital certificate does in an online world. It tells the application who you are, and then visa is basically what tells the applications, or it tells the authorities in the real world what you are allowed to do when you have that visa, whether you are a tourist or you can work in the country where you're traveling, or you can study over there, or you can do all of them. That's exactly what IAM does. So IAM bit, the customer ID solution that you see over here, basically does that. It tells different applications that with this identity, what this user can do, what role he can play on a particular application. That's called role-based access. Then we have single sign-on, where you have a single user. You want to have single set of credential, but you want to give access to multiple applications, and this is what single sign-on does. Identity federation is a typical scenario where you want users who have their credentials being issued by one organization. You want to allow those users to log in to a different organization, but you don't want to issue them new set of credentials for that new organization. So these two organizations basically will have some sort of identity federation partnership between them, and then these identities can be trusted. A typical example could be when you log in or you want to create an account on some web service provider. You don't want to create, or you don't want to have punch in all the information like your name, your address, telephone number, email address, blah blah blah. They give you an option that you can create your account using your LinkedIn credentials or your Facebook credentials or Google credentials. So these identity providers like Facebook, Google, Yahoo, or Gmail are the identity providers, and that's what comes from identity federation. So between your service provider and these identity providers, there's some sort of federation, a partnership. And then of course there's a last platform called Confirm. So Confirm is business transaction confirmation. It could be in the form of a digital signature. You can apply a digital signature to a transaction. You can monitor a transaction and see what is going on in that transaction, and basically give some form of confirmation, approval to that transaction. So this covers at a very high level what we do with our IAM services. Lastly, towards the end of the session, I would like to talk about some of the third-party integrations, as I mentioned earlier. And we have a lot more integrations. I'm just focusing on a couple of them, which are quite interesting. We have been seeing a lot of traction in the last few months around these approaches, these techniques. The first one I want to talk about is a typical digital signing scenario. Let me talk about the use case first. A lot of times we have customers who have their PDF generation softwares or any document generation software. PDF is the most common, obviously, and or they have a document management system, and everything is working just fine with regards to their PDF or document generation and then management. The only piece they're missing is how to digitally sign these PDFs. So normally the the approach we have, or the moment we say, a moment I tell you that I have a software which can do the document management part, but I'm not able to sign, what do you suggest? The first thing that comes to our minds is APIs, application programming interface. And what we do is that we get hold of an API, figure out what API suits me, whether I have a Java application or .NET application, and then I get the corresponding APIs, and then I make a source code change to my application, make the API call, and then this API gets the PDF or the document signed and give it back to me. Now you can have free APIs, which could be totally free, like iText, which is the most common. You could have different service provider or a technology partner who can be giving you the APIs. But the problem is APIs are APIs. Now it takes a little bit of effort. Sometimes it takes a lot of effort depending upon what kind of resources you have to get these to make these API calls into your application. What if it's a third-party application and you don't have access to the source code? Or let's say you do have access to the source code, but you don't have the programmers, the relevant programmers with the relevant experience who could make those API calls. And this is what I've seen as a typical pain point where customers usually take between 1 and 3 months, sometimes 5 or even 6 months to get this job done. Now, to overcome this particular problem, we have a very interesting solution from one of our technology partners, which in very simplistic terms you can say the smart folder solution. So what this solution does is that it's a software, it's a signing software which is deployed on your signing server. It can be deployed on laptops and desktops as well. And all this does is monitors a folder. It can monitor more than one folder. And as soon as a PDF lands into this folder, it is picked up, a hash is generated, it can be sent to the HSM. GlobalSign provides hosted HSM as a service, and then the signed hash comes back to the signing software on the server where you have deployed. It then embeds into the PDF, and the signed PDF is ready. So it picks up the PDF, gets it signed, and given back to you. This is exactly what you do with an API, but without having to write the change the source code or having to make the API calls. It can give you the exact same solution, the exact same end result. The solution is very, very cost effective. Um, I'm not sure whether this is the right platform to talk about the commercials, but on a 5 year tenure, the cost of the license, the cost of the 5 year support could be something less than two and a half, could be around $2,500 or $3,000 on a 5 year tenure. So it's extremely cost effective. It gives you exactly what you get with API integration. Certificate provisioning on non-standard devices. So what we spoke about AEG, which can help provision certificates on Windows domain joined machines. We are also going to offer we are certain non-Windows devices like Linux and Macs in near future. But let's say if you have a completely heterogeneous non-standard environment where you have all sorts of web servers, endpoints like Linux and Macs, and you want to provision certificates even on non-standard devices, uh, mobile platforms which are not very effectively supported, and then what basically we do is that we have a very strong provisioning engine from one of our technology partners who can help implement, or rather who can help provision certificates to these different uh, endpoints. It could also be a situation where you want to completely automate the certificate provisioning on your web servers, and then you even want the certificates to be the binding of the certificates with the websites to be completely automated. Most of the solutions help you get a certificate issued on a web server, but then you have to manually bind the certificate to the websites, because on a particular web server you could have more than one website. This technology partnership that we have helps you overcome this challenge as well. And last, uh, technology partnership that I wanted to talk about. And before I talk about that, I wanted to ask you a question: that how many of you are aware that there are techniques available, on contrary to the conventional traditional approaches, where you use a hardware smart card or a TPM, trusted platform modules, to protect the private keys? These are the conventional approaches. These are robust approaches to protect the private key. How many of you are aware that there are software techniques as well, where you can protect the private key in exactly the same way as you would do in a hardware container? I'm not talking about PFX or P12 file. I'm talking about approaches which guarantee that the private keys cannot be skimmed once the key has been generated or provisioned on a particular machine. So this is called software-based private key protection, and I've had the privilege of working with one of these technology vendors in the past. And of course, we have more similar technologies to offer. The biggest advantage of these technologies is that you don't need additional hardware to be provisioned. There's no additional hardware cost, no logistics, no reissues of the hardware if the users lose it. You don't have to have specific hardwares which come with TPMs, because again, TPMs have a cost associated with it. Not every laptop or a desktop or a mobile phone today that we use has a TPM, so there are limitations as to what you can do with hardware-based approach. This particular technique, or these kinds of techniques, help you ensure that a private key does not leave the device once it has been provisioned. It's extremely important when it comes to situations where you want to ensure that the private key does not leave a web server. Let's say you have an SSL certificate and you fear that one of the administrators might access the server, copy the certificate and the private key outside, and then maybe launch a phishing attack. Quite possible, because normally you protect the private keys all in the software, standard software, and putting the certificate in the key store. And these kind of threats can happen. The same can happen to an SMIM certificate, it can happen to a client auth certificate, it can even happen to an IoT device where you want to ensure that the private keys are not going out. These techniques basically help you ensure that private keys are protected at all costs. So this brings me to the end of the session today. I hope it was helpful to you. And if you have any questions, we can always take them up. Thank you for your time. Have a nice day ahead. Bye bye.